Welcome back to Let Us Learn to Lead video series on free open source software prepared by M. Srinivasan, Training Associate Mathematics, Kendra Vidyalaya Sangathan, Zonal Institute of Education and Training, Mumbai. Self-learning contents in video form on GeoGebra, dynamic mathematics software is presented at this video series. To view the contents, you may join Google Classroom by using the class code 73AUMBO. In this video, you will learn designing worksheet to explore circle part 3, area of circle and segments. For preparing this video lecture, I used Windows 10 operating system licensed version, GeoGebra 5.0, a free open source software, and free open source screen recorder software. Let us start. Let me show you what type of worksheet we are going to design. We are going to tell what is the area of a circle. Definition: it is the region occupied by the circle in two-dimensional plane. We will try to draw circle of integer radii. It is left to you. You can have radii with increment of 0.5, 0.2 and so on. Now we want to show the area. It is very simple. Right click, go to the object property. In that color you are having this opacity, just increase it. Then you can tell them that this is the area occupied. In any color you can show. Actually it is by default it is taking black color. Well, now we will explain them what they mean by the circumference 2 pi r. By changing this n, radius changes and they can calculate the circumference. Then we can declare the area of circle. Once again they can calculate the area of the circle. Remember here the value of pi is taken as 3.14, but the calculation, inside calculation, it is more approximate. Okay. Now we can show them what do you mean by the minor segment. Already in the previous video we have discussed it. Here we are going to find the area of the minor segment. We will declare the minor segment. We will draw the triangle and we will tell them what is the area of the minor segment. It is the area of the sector minus area of the triangle which is on the top of the segment, and we will declare the area of the sector and we will find the area of the triangle. These two are directly obtained from GeoGebra, and you can find the area of the minor segment, and we can declare what is the major segment, and we can declare that area of the major segment is area of the circle minus area of the minor segment. And already we have found the area of the circle, and area of the minor segment is obtained, and we can ask them to calculate area of the major segment. And here the calculation is also shown, and it is being shown in a colorful way. Let us try to design this worksheet from scratch. For that, I have taken GeoGebra Classic 5 worksheet. Geometry view is selected, and in the option rounding off to 1 decimal place, labeling of new points only. As usual, we will start with the heading exploring a circle, area of the circle and the segment. Go for it. I will paste it. Okay, now remember, we are going to ask the children to have this worksheet, and side by side they will be doing the calculations also. Suppose if r is known to them, and they will be calculating the circumference and area and so on. Okay. For making a circle, we will take a slider. Here I have taken integer. It is left to you. You can take numbers also with increment as per your convenience. I have taken it. Let me go for the circle with the center and radius. I am putting it, and then radius I want it to be a variable, therefore n. In the slider I have taken it as n. Okay. Normally we used to rename it as O. Already we have done it 1 or 2 times. We will rename it as O. Now we will start to explore one after the other. We can tell the children that what is the meaning of area. Okay, before we go there, okay, I think let us try to ask them to find the circumference also. Okay, I think circumference no need to define, already we have defined. Okay, we will take a point on the circle now. Okay, then we will try to join it, this OA, and you know that this OA is the radius, it will increase and increase and so on. When you right click it, and then this segment is F. Okay, the segment is F, or it is N actually, whatever may be. Segment is F. You have to remember that. Kindly note down the variables being fixed by GeoGebra, so that while you are using anywhere, it will be easy for you to have it in the text box. Therefore, you can now tell circumference 2. From the symbol, you can go for this pi, and you can go for this r. Okay, is equal to, you ask the children to do the calculation. 2 into from the symbol, you can go for this multiplication, and 3.14. Again go to the symbol for multiplication. R is here F. Okay, is equal to. Okay, now I'm just keeping it. Now let me try to tell you that how to get the circumference directly. Very simple. Go for here, distance or length, simply touch the circle. You see, you got the circumference. When the circumference is being done at C, or again we can put the value in the object property directly. In that, go to the text, in that circumference at the end of it, we have done, ask the children to do the calculation. Okay, we ask the children to do the calculations. After the calculation, they can get the value directly. In that is equal to, from the object you see the circumference. It's very simple. Okay, now that when the child is coming and changing it, n is equal to 10 and so on, they can get the circumference. Okay, this you can remove it also. Okay, once again we can go for the definition of the area. What is the area? We will tell the children. Okay, we can show it visually also. This option is there. We will try to go for it. Okay, now we can ask the children that area of the circle. Now in the border of this circle, go for this object property. In the style of it, you can line thickness little bit increase, and then in that color you take any color, for example, and then try to move it like this. Okay, you see, now the children can understand what you mean by that area. You can tell them that, okay, I'm moving it. Actually, what is being covered? The area is being covered. Okay, well, I think this is a way of just explaining to the children. Okay, well, now what is the area formula? You can go for it once again. Therefore, area is equal to, once again, pi is already there. You can go for this r, and from the symbol you can go for this square, and you can write it as 3.14. I think it is approximation which we are normally telling to the children, multiplied by, within the bracket, you know, radius, it is F. Okay, then go for the symbol and go for this square. Okay, now remember, okay, I'm just leaving it as it is. Okay, now is it necessary to calculate area? No, this giving you directly the area. You see, area directly, you got it. Area of C is equal to 78.5. Actually, you remember that 78.5, what is the name given to it? Actually, remember, it is given as small a. That you have to note down, because GeoGebra is taking as per its convenience by default one alphabet. It will be going on fixing it for segment, fixing it for area, fixing it for circumference and so on. But you should remember that. Therefore, here I can object properties, in that basic text I can come back, and I know that this is nothing but small a. Good, you got the area now. Now you can ask the children to come and check out the area. Now when it make it into 10, you know that it is a 3.14 something into 100. Therefore, it is coming as 314.2. Okay, well, now it is being done, approximated by GeoGebra. Okay, now we will go for it and then show the object. Now let us try to go for finding the area of the minor segment. Already we have discussed that in the minor segment how to get it. Go for this point on the object, put a point here, put a point here. Okay, then go for this arc, circular arc, then touch this O, touch this B, touch this C. Now you got a arc at the bottom. Right click it, go to the object property. In that color, give a opacity to it by giving some color to it. Okay, now you can tell the children that what is the minor segment over here. by taking a point here also. Therefore, that point has come here. Therefore, in the text box, you can now type BDC is the minor arc. Okay, now to get the area of the minor arc, we want the area of the sector. Therefore, go to this once again to this circle. In that circular sector, touch this O, touch this B, and touch that C. Now you got a sector now. Remember this GeoGebra, that sector I will go to the object property and little bit opacity I will increase. Okay, now you know that the area of the sector is automatically obtained by GeoGebra. Let us see what is the value it is giving. Actually, it is maybe E. You see, this is E, and I'm removing it, it is going. Therefore, you have to note down. Therefore, E is equal to the area of the sector. You have to keep it in your mind. Okay, now let us go for telling the children that how to get the area of this minor segment. For that, we have to do something. We have to go for this segment BC. Then we have to go for one more triangle. I will go for this triangle O, B, C and O. Well, now we have to declare to the children that what is the area of the minor segment. Area of minor segment. The minor segment is BDC is equal to area of the sector. The sector you can call it as OBDC minus area. It is actually calculating directly area of triangle. You can make use of the symbol. There is a basic symbol is there, no need to type it. The triangle OBC. Okay, OBC. Okay, well, good. Okay, now remember that this sector area and the area of the triangle are automatically obtained from this GeoGebra. I will show you that in the graphic part. Anyway, the child will be doing it. Area of the sector formula you can give theta by 360 multiplied by pi r square. You can give the formula and ask them to find the area of the sector. Okay, now here already I have told you that in that algebra view, if you go and have it object type, here it will go and tell you what are the triangle. You see the triangle, it is a T1. Now already we have noted down E is the for the conic. Okay, you see conic E. So E, okay, and this is the T1. Therefore here it has got up to G. Therefore I can now go for one more variable. Small h is equal to, you know that it is the area of the sector, it is E, minus the area of the triangle, it is T1. So very simple. Now you got that the value of h now. The value of h is there. Now you see the value of h I have already found now. It is equal to 9. Therefore, now you can come back. You have to note down that what is the variable it is being there for it. Therefore, you can go for this text now. Therefore, area of minor segment is equal to the area of the sector from the object properties. It is there E, okay, minus. Then you can go to the object property of T1, okay, is equal to. Now we have already done that calculation and we have given h to it. Okay, you got it now. Okay, 21.9 minus 12.4, this is equal to 9. Therefore, area of the minor segment, you got it now. Okay, now let us go and tell the children that what is the major segment. The same thing, go to this circular arc. Now instead of touching OBC, you touch O, you touch C, you touch B. You got it now. Escape, go to the right click, go to this object property, and then you can give a red color to it, and you can give opacity like this. Now the child can understand what do you mean by that major segment. Now you ask them what is the area of the major segment. The area of major segment is equal to area of circle minus area of minor segment. Area of minor segment. Okay. Now you know what is the area of the circle A, small a, it has been given here. An area of the minor segment, just now you have found it as h. Therefore, go to this view and then go for this input bar. You already had h, therefore you go for I. I is equal to area of the circle is small a minus the h which you have just now done. Therefore you put is equal to now. Now you are seeing over here in that graphic view, this I is being calculated 69.5 directly by this GeoGebra. Therefore now we can go to the geometry view once again. Again we can go for this text. Therefore we can tell the children that what is the area of the major segment is equal to the area of the circle from the object property. It is nothing but small. You have to note down, it is very easy for you. Minus then just now we have done h as the area of the major segment, sorry, minor segment. Therefore it is equal to, now we have done the calculation by ourselves. We have put I for it, therefore is equal. Therefore area of the major segment. Okay, suppose if the child is asking you, sir, area of the minor segment formula if I want, then that also you can do. Go to this ABC, you can make use of this latex formula. For example, area of sector. For example, they want the area of the sector. I will ask you to how to type it. For example, space of then space sector, okay, is equal to, then you can tell them theta by 360. Therefore in that you can go to the symbol and you can put it as theta or alpha, whatever may be, 360. Okay, then in the symbol you can go for this multiplication, and you can go for pi, and you can go for r, and you can go for this symbol as square. Okay, now this is actually area of the sector. You can show it to the children also. That's what I'm telling. In that making use of that latex formula also, you can show them the what is the area of the sector, and the area of the sector is directly calculated by GeoGebra. Now this is the way of having the navigation bar. You can come back and then one after another you can tell the children that you can tell them what is the circumference, the area you can explain, and you can right click it, and you can go to the object property, opacity. By using opacity you can show them what is actually the area of the what do you mean by area of the circle. We can ask them to calculate the area. Then we can ask them what do you mean by that minor arc. After knowing that what is the minor arc, we will ask them what is the area of the minor arc. Then we can go for area of the major arc. Therefore all the ideas which you are going on explaining over here can be explained to the children in a nice way, and with a way of interactive way, and in a colorful way. Thank you. Let us learn to lead.